So, hello everyone. I'm Jonathan Schemoul, founder of the Aleph.im project, and I'm here to talk about decentralized computing, decentralized storage, and computing as well, and like how can we bring AWS-like service in a decentralized way. So, without further ado, let's start with a little video, a very quick video presentation of the project.
Internet is broken. What used to be a decentralized network powered by millions of self-hosted servers is all but gone. Today, every image you share, every video you watch, every form you fill, flows through centralized networks controlled by just a handful of companies. But there's a change coming, a monumental shift. And at Aleph.im, we're supercharging the transition to a new decentralized era. An era that provides fully decentralized cloud storage, computing, and identity services, powered by incentivized self-hosted servers. Built from the ground up, our unique architecture blends both off-chain and on-chain technologies to support an ever-growing constellation of blockchains and companies. We've built the tools that allow you to store any file of any size on our proven decentralized network. Protect your precious NFTs securely on our network for eternity with our pioneering backup dApp. Unleash the power of our decentralized virtual machines, allowing you to run dApps in any language that can also read and write to blockchains or be triggered by off and on-chain events. Be empowered to store, build, and launch incredible things in this new era of decentralization. Join us at Aleph.im.
Thank you for watching this. What we are aiming to do, let's get a bit back into history. First, there was Web 1. Web 1 is just servers, people accessing servers, getting data, getting pages, whatever, and anyone was creating his own web page, hosted on his server, and it was decentralized from the ground up. It worked. And then came Web 2. It started by having hosting providers where people weren't hosting themselves at start, and then they moved to using hosting servers. And then those hosting companies became bigger, and they started having databases behind websites. And it all worked because you could have your web services, etc. But it all started to become really centralized. Right now, we have a world of silos. You have Facebook, you have Twitter, and many more. And they themselves are all hosted on a handful of companies. You have AWS, Google Cloud, and a few others that are trusting the web, which is problematic for a lot of reasons. Freedom of speech is one. Deplatforming is another. And the freedom of speech starts becoming a big issue in Web 2 as well. Because let's say you say something that isn't agreed upon by the owner of a platform, they can just remove your account. They're just a company. They can do whatever they want. And that's how we come to the Web3 era, where we try to decentralize web services, decentralized servers as well, and decentralizing all these kind of services, trying to remove the middleman. And this comes thanks also to cryptocurrencies, because cryptocurrencies allow to add a monetary part to it. And we are helping this by trying to build an equivalent of, let's say, an AWS equivalent based on decentralized technologies. So we are providing file storage database storage, because let's be real, most of the websites are just databases. So it's a bit like Firebase, if you know it, but usable with like your crypto wallets, crypto accounts, because the whole network is based on private and public key cryptography. And also computing. And our computing system is based on micro virtual machines, a bit like AWS Lambda for those who know what it is. And because there is that part about blockchain and like economic incentives, we are compatible with most blockchains today. Ethereum and like all the EVM chains, Polkadot, and like all the substrate-based chains, Cosmos and all the Cosmos SDK chains, the Binance chain as well, Solana, Avalanche, Tezos now, and many more to come. So how are we doing it in application? So we have an on-chain layer where we accept messages signed by wallets of these different chains. So like if you have MetaMask, you can sign a message on Aleph. If you have Phantom from like Solana, you can as well. Well, like it goes on. We also write messages on-chain for security. We don't have our own consensus, but we use the Ethereum consensus as a security layer, so that history can't be like changed afterwards. And then we have our own peer-to-peer network. Our network is consisted of like 100 nodes, 100 core channel nodes right now, which are the controllers of the network. I will come back to like it later, and more than 300 resource nodes. And for the communication between those nodes, we are using lib peer-to-peer, using FluteSub and GossipSub, and also IPFS on the PubSub layers of IPFS as well. Then we have SDKs that are talking with like all our ecosystem, which are in JavaScript and Python, and we even have one in Java and Go as well. And the application layer, like where anyone can like make its own application on top. We have a few demo applications which are available. I will make a quick demo later about it. So I was talking a bit about the network. So when I'm saying that, it's because we have what we call the core channel nodes, which are the controllers of the network. They are in charge of verifying each message, on that each message is like indeed signed by the correct address, that like the hashes are okay. If it needs, it will go and download a specific data which is linked to like that message. And those nodes are well live and they work, and they provide the database and file storage part for now. And we also have the resource nodes, which are those that are actually providing resources. Like, let's say you can create a resource node that will be a virtual machine supervisor that will provide resources to like the whole network. And those nodes, they get reward if they are working, because people pay to like use their resources. There is a bit more to it. We'll come back to it later. And you might have seen a few colors there. It's because we have channels on the network. It allows to have like some kind of separate sub-networks. And one resource node can like be subscribed only to like certain channels, and then it allows infinite sharding. Hence the name Aleph.im, because Aleph is the cardinality of the infinites, like Aleph 0, Aleph 1, etc. And Aleph.im is because it's infinite instant messaging. So what if you wanted to like operate a node? For the core channel nodes, which are again the controllers of the network, they are providing storage and computing resources. They control the network and how the resources are like provided, and they get reward in Aleph tokens. To like have one, you need to have a certain amount of Aleph, on like have a certain amount of Aleph delegated to you in staking. It's to force you to like have skin in the game. It's basic game theory. For the resource nodes on the other end, for it to be accepted by the network and targeted by the load balancers, etc., you need to be vetted by a core channel node. So like, for example, you can go and see one core channel node and say, okay, here are my credentials, here are my servers, can you please vet me? And then if they say yes, you get added to like the network, and you don't need any collateral to like create a resource node. And those nodes provide computing. The computing resource nodes are currently live. The storage resource nodes aren't live yet, and we are looking at having some gateways toward networks like Filecoin, for example. And they are rewarded if there are files stored on their servers, or like if micro VMs are called on those servers, etc. And we also introduced what we call a minimum wage for those nodes. I will come back a bit more into it later. So at the very heart of Aleph, there is our token itself. I know that's not really the goal of this conference here, but for like a resource sharing system, you need to have a currency in it. So the currency is used to pay for storage, pay for computing power. End users don't necessarily need to pay for it because the application creator can pay for its own users. But if the application developer stops paying for its own user, let's say, for example, you have an IoT provider who is creating a coffee machine, okay? You have a connected coffee machine. As long as the provider is there, it works, that's nice. But once the provider says, okay, I don't want to like support this machine anymore, your coffee machine doesn't work anymore because it doesn't work without its cloud. Now, if they were using Aleph, users could say, okay, no, please, I want to pay for my own use. Please maintain those frigging servers. I want my machine to continue working. And then it also applies to games, to like any kind of service, SaaS, etc. And that's where it gets interesting, because if you have deployed an application, it can continue living without you being behind it. So we are effectively getting the same kind of resiliency that there is in the blockchain world with like smart contracts. We are getting it outside of it for like actual code, IoT backend, SaaS backend, or whatever. And then those tokens are obviously used to like reward the storage and computing providers, so that they continue putting servers online. And then they are also rewarding the core channel nodes, which are the controllers of the network, the nodes that are in charge of having a healthy and working network. And there is also the stakers there. The stakers are those that are in charge of saying this core channel node is like behaving correctly or not. And if it's not, they can say, I don't want to stake there anymore. And if they don't have any enough stakers, they get offline and they don't do any work anymore. And same for the resource nodes which are linked to them. So it gives the average user and average community member of Aleph the power to choose which node should be on or not. And it's also used to pay synchronization services with blockchain, because when you write on Ethereum, it can be quite expensive. And we are also adding rights to like Solana, Tezos, and a few other blockchains soon. So a bit more inside the resource node and the system with which they are paid. You have the stakers which are staking on one core channel node, saying, okay, this core channel node should be live. And then the core channel node can choose a few resource nodes that are working with him. And where it gets interesting is that if each one can like currently, but those numbers can like change with time, he can have 3 minimum wage resource nodes that are paid no matter what happens. Now it gets weird. Why would we pay for resources even if they aren't used? Well, it's a bit like if you see Uber coming in a new city. Well, they are paying drivers going around the city even if they don't have any riders, because you need to have drivers so that riders can like actually ride. So at start, while the whole economics isn't yet working well, you need to pay people to like run servers no matter what. And there isn't only that. We like also have what we call currently holder tier, where you just hold Aleph tokens and get micro VMs running. You just hold Aleph tokens and get storage. And this is paid by this minimum wage. And then if they want to like have more than 3 resource nodes, they can, but then they will only be paid if there is actual use on the network, which makes sense. So all this brings us to like a lot of use cases that can be done with Aleph.im. We can have document certification that goes along with document management systems. You can have real-time decentralized applications because you have around 100 milliseconds for your message to be accepted by nodes. So it's like fast enough that you don't see actions happening when you are actually on a DApp. You could even make a Twitter-like DApp. You could store KYC and KYC metadata. One of our partners is already doing it, which is Anima. Anima is proposing a decentralized identity solution based on Aleph.im, where it encrypts the whole passports, identity card, etc., plus all the metadata on the Aleph.im network. And you, as an end user, if you did your KYC once, you can download it and like re-encrypt it for like another provider, etc. So it's kind of cool. If you ever use exchanges or stuff like that, being able to like reuse your KYC is quite nice. And also it allows to get that data on-chain through oracles so that you can be certified as KYC passed on like decentralized exchanges and things like that. You can also host a website, and then you can host the static website using IPFS on our network, and you can even host its whole backend. Since we now have micro virtual machine, you can put your whole backend code inside a micro VM as well. You can handle DEX order books, NFT metadata. We are doing that with Ubisoft as an example. I don't know if you have heard of the Ghost Recon Breakpoint NFTs. The files are stored on the Aleph.im network, and the NFT metadata are generated on the fly by a micro VM, so that off-chain events in-game or like on-chain events on Tezos change the actual metadata that is served to like OpenSea, etc. So that's it for the use cases. We will go after that with some kind of demos on that. And there is also indexing, which we are doing on Solana as well. We are indexing like 70% of the Solana ecosystem currently. We are indexing a lot of projects. We will show a few indexes as well, and this is based on our micro VMs. And I will now let Hugo from our engineering team to present how the micro VMs actually work.
Thank you, Jonathan. So I'll introduce you to how the virtual machines on Aleph work. I'll go quite technical. I hope that's okay for you. I think this conference was quite technical, so I hope you will be interested. So on an overall level, what we have is the virtual machines run on compute resource nodes, which are supervising, launching, stopping the virtual machines. And they're connected to the IPFS networks, to different blockchains, to the Aleph APIs and databases. And we also have some load balancers to provide HTTPS access to the virtual machines. And they have access to the internet as well. So in a very simple way, the clients connect to the VM supervisor through a load balancer and reverse proxy usually. And then the VM supervisor is in charge of running the user process inside virtual machines that can talk to the Aleph nodes. In a more technical way, this is how the whole architecture looks like. If we focus on the bottom right part, so we have our user process here, the program that the users create. We have that's running inside the virtual machine, which is a Linux system. So we are using a software called Firecracker, which allows us to have virtual machines that start really, really fast. In about 400 milliseconds, we can have the whole cycle of booting the virtual machine, running the user's process, getting the response, and sending back to the client. And then the virtual machine can be stopped, so users only pay for what they really use, instead of paying for resources that are constantly up. We have a custom init that's doing this, and it's discussing with the VM supervisor. You see a bit above. I'll use the mouse. No. So we have here the VM supervisor, which is discussing with some kind with a vSock. So it's some kind of socket. You know, you have UDP, TCP sockets, Unix sockets. vSocks are a kind of sockets that are specific to virtual machine supervisors, QEMU, Firecracker, and others. So they're discussing with this custom channel. So here we have the user's process, and then we have different volumes you can see on the right. The first one you can see here is the code archive that's containing your program. So usually, instead of bundling everything in one big file system, we have what we call a runtime, which is basically a Linux root file system that you can see here on the right. That's mounted read-only, and it's shared with by most virtual machines. You can create your own, but for most use cases, using the same as everyone and something that's maintained by Aleph for security updates is more convenient. You have your own program. Then you can add immutable volumes. Let's say you want to add some static data that has to be accessible to your VM. For example, we gave a workshop yesterday with machine learning, and we had about 1 gigabytes of pre-trained machine learning models for TensorFlow. You can just mount it as an immutable volume, and it's basically the supervisor will download it from the Aleph network, so from IPFS, and then make it available to the VM. And you can have mutable volumes where the VMs can read and write, so they can store data, for example, at a local database. And then we have the Linux kernel, and we have a temporary overlay file system, so the process can write files on the VM, but these will be discarded as soon as the VM is stopped. Then we have also like the environment of the VM. So in the bottom, we can see we have a tap interface that's connected to the network interface to give access to the internet. There is an option you can choose if your VM does have access to the internet or not. So for security purposes, you can choose this, for example. And then we also have a guest API. So we provide some specific APIs to the VM that allows some advanced features that are provided by the host. For example, we have a shared cache. So if your program wants to store a few simple variables locally that have to change over time, but remain, then you can just store them in this cache. And we also have this API also allows the VM to use to publish messages on Aleph that are signed by the host system. And that also has a privileged, pre-configured way to access the Aleph network, the databases. So it's pre-configured for the VM. You don't have to think about where to connect, what are the settings, what are the parameters, the way you would if you're using it on your laptop. So that's the main architecture of the Aleph virtual machine supervisors. At the moment, the first implementation we have works in the same way in a Lambda function. So it's start a VM when it's called. We're working on adding the support to have permanently, constantly running VMs. So you can say, well, my VM needs to have a WebSocket connection that's persistent. So this model doesn't work for us. We're working on adding this as well as adding the support for data pipelines. Say, I want to train some machine learning or do a lot of processing. I want just to schedule it so that the network does it whenever. And instead of having to be instantly, and to have networks of dependencies. So that's it for the architecture of the VMs. I'll hand the microphone back to Jonathan.
Thank you, Hugo. So now that we have seen a bit into details how it all works, we can talk a bit about apps, integration partners, etc. We are working with Ubisoft, as I said earlier. We are working with quite a lot of companies, projects, etc. This is just a very, very small extract. There is way more. Synapse is doing the Anima decentralized identity I was talking about. Serum, Radium, Saber, Orca, etc. are like all DEX on Solana for like whom we are doing indexing using our micro VMs. Neon is the implementation of EVM for Solana, and we are doing indexing for them as well. Request Network, we are duplicating their IPFS cluster using the Aleph.im network so that the invoices are like available and backed on a decentralized network and like available in the broader IPFS network as well. We can focus a bit on one of our decentralized applications, which is what we call MyAleph, which is some kind of a Dropbox clone. So here it's this application actually. I just created an account and logged in. I can set a name, boom, my name. I can say my bio here. I save it, and you can see everything is instant. And then I can create a new folder, Paris P2P, boom. And I will upload a file in there. You can go and see yourself this application and use it. It's called mybeta.aleph.im. It's linked from a lot of our outlet. What can I upload that isn't too sensitive? Yeah, okay. This picture. So it's uploading it. Bear in mind that I am using my phone as an access point. So right now it uploaded it encrypted. It encrypted it for my own private key. On like only myself can like decrypt it right now, and it's all end-to-end encrypted so far. If I click on it, it will download it and show it in the browser, if my internet is fast enough, that is. And I can also make it public and share it. And if I make it public and share it, it will give me an IPFS URL that I can then share directly. So I can get a public link, I can paste it and open it, and then I can give that link to like anyone, and it's served from the public IPFS gateways. So, oops. If we go on the Aleph.im Explorer, we can see that there is an address here, which is us, actually. If I don't have a demo effect because of my lagging phone network, I will, oops. So we can see that we did an amend, which is an update to like a database entry. We created first a database entry with this user. I will open it in a new window while it loads. And then all the metadata, the name, etc., is now in clear. It was previously fully encrypted. Yep. So we did 2 store messages. Each store message is a command that tells the network, please store that file. The first one was the encrypted file, and the new one was a non-encrypted on IPFS. And if we compare the first database entry, which is here, everything is like encrypted. We can't read it. And the other one that we are seeing is an amend on that first database entries of metadata, where like all the metadata is in clear. And if we look at what this address did as well, it also wrote on what we call aggregate, which is a key value database system. We wrote on the key profile, the subkey name, and the subkey BO. And then it's all available instantly. The good part is that you can reuse like the same aggregates between multiple applications if you want. So we have seen a key value database and document type database. Let me create a new node here. I will create it in a public way. Boom, testing. A Paris peer-to-peer. I will put it public. I save it. I can share it, and then I have a public link. And that public link, if we look at it, well, it's saying whatever we said. And the good part is that you can amend your database entries. Let me save it. I update that page, and boom. And like that database entry, which has this hash up there, has been updated, and you can see it there. It has a lot of application. Like you can do that for like a medium-like blogging application, which is there. You can play with it as well. Technically, right now, we just added login with a private key and like MetaMask, but we could add Phantom, whatever, because any supported chain can sign messages on the Aleph.im network. So like this application can be accepting users from like Tezos, Solana, whatever. We don't care because we aren't really directly talking with blockchains there. And then if you need to talk to blockchain, you can have hybrid applications that are getting both on-chain and off-chain data. And that brings us to like our indexers, which might be a bit awkward because, okay, yeah, so you can see that it flatlined because Solana has been a bit stuck since yesterday night. But this is the Serum market indexer. The Serum analytics is quite interesting because our indexers, which are running inside micro-VMs, are crunching a huge amount of data. And if you know Serum, it's millions of trades, millions of orders per day, which are constantly created, moved, etc. And we are also doing it for Neon. Oops. Neon. Oops. Sorry. And Neon is the EVM on Solana as well. And here you can see all kind of statistics which are compiled and gotten from like on-chain data, which is processed by micro VMs. And then you get the result in a browser using GraphQL. We will be open sourcing fully our indexer framework with support for Solana, obviously, but also EVM chain, Tezos, and a few others. On the end of dynamic NFT use case, I talked about Ubisoft before. This is getting data from Aleph, and you can see that there is the owner history, and you can select another. Yeah, and then each NFT has its own video with its own ID engraved inside the video, and then you can see each one, and like everything is stored on Aleph file system. So that's it for this part. Boom. And yeah, our own website is a CMS on Aleph as well, which I find pretty cool because we are eating our own dog food. And well, there is a lot of other use cases which are live, like I said, Anima. Perhaps I can show a nice video of Anima, by the way. Oops. Let me check. Boom. Anima protocol. Yeah, I can show a quick video about Anima. So yeah.
Identity work. This is Anima, your digital twin and your self-sovereign identity online. It acts as a secure hub for all your official documents and helps you share them instantly. Let's see how it works, step by step. To create your decentralized identity, you will start with an identity verification process to check who you are and validate your documents. Once that's done, your Anima and its credentials are created. Credentials are validation stamps stored in the Decentralized Identity Protocol. Each credential is linked to a document in your Anima thanks to a unique identifier. Anima uses your wallet as an authentication system, and your personal documents are encrypted with its public key. Thanks to this encryption process, only you can decipher your Anima. Your Anima and its encrypted documents are then stored on Aleph's decentralized infrastructure. Once your Anima has been created, you can use it on web platforms to make your identification process easier when required. Just connect your wallet with one click and select which document you need to disclose from your Anima. The platform will instantly request its credentials from the DID protocol, and you will be granted access.
So this was a quick video about Anima, which is a decentralized identity protocol that I was talking about before. And the whole Aleph.im network enables this kind of use cases as well. And the good part for Anima is that whenever we support another chain, they can support another chain as well. And the good part for us too is that any Aleph D app can now have like KYC and like decentralized identity quite easily thanks to like that integration. Yep. So here are a few links to like our developer hub, which is a Gitbook document which is quite complete. You can talk with us on Twitter or directly on Telegram. And if you are a developer, just tell us on Telegram and we can invite you to like our developer group inside it. Thank you very much for like your attention. And if you have questions, please.
Hello. Hi. I have a question regarding the NFTs.
Yeah.
Just wondering how Aleph can make our NFTs secure in a decentralized way.
Well, on the NFT side, for those that don't know this, like what is on-chain is just ownership, and then you have a link to a metadata JSON file, which can be hosted anywhere. Now, a lot of people are now using IPFS for it, which is quite cool because you can't change like the content without changing the hash, and that makes them somehow immutable. But now remains the question of who will host your NFT metadata, and then we can host it on IPFS for you, for example, and then host all the pictures, video, etc., which are linked on the network as well, so that it can't go down. We are also working with Tezos and Ubisoft, and we will likely do it on like other chains as well in the future, in a way so that when you mint your NFT, you can lock Aleph tokens inside it to pay for storage somehow forever or like for really, really, really long time. And then there is also the question of like dynamic NFT, because a lot of the times you want your NFT to be like dynamic. You don't want your NFT to be static. So there is multiple ways to do it. You will either use a centralized server, which will generate your metadata on the fly, or you will generate it fully from like on-chain code, but it will be really costly and really limited. Well, here you can put all that generation code inside a micro VM and write it in like any language you want. And you can even get data from like our indexer to like get data from like on-chain event, get data from off-chain event for whatever you want, a web service, the weather or whatever. And then generate it in a verifiable way, because anyone can like download the micro VM, run the same code and verify that the result is good.
Thanks.
You're welcome.
Any other questions? Please.
Hello, very interesting. I've got a question for the Dropbox clone.
Yeah.
Maybe you mentioned, and I didn't catch it. So you're running a pinning service of some sort, or a storage cluster, where if I go and upload a file, it's going to be stored in your cluster, and then if I want to retrieve it or make it available to others, it loads through IPFS gateways. Is that how it works, or?
Well, actually, in the API, you can choose whatever you want. You can upload encrypted document on IPFS or like just on our storage, and like delete, and like any way you want. In this application, encrypted data is stored only on Aleph, and then once you make it public, it pins it on IPFS for you. So that's how it works in that case. And here, the core channel nodes are actually pinning your data. Once we have the storage resource node, they will be in charge, or like either storage resource node or like a gateway towards like Filecoin or like others. We are still looking into it, but yeah.
Okay, got it. Thank you.
Okay, great. Okay. Very interesting press, by the way. Everybody was thanks.
Hi, very nice talk, thanks. I was wondering, do you have any mechanism to ensure that your virtual machines are executing what the owner wants, or are you planning to add some support like SGX attestation or something like that?
Yeah, it's actually planned. Perhaps Hugo has more to say about it, or Olivier, I don't know. Yeah.
Hi, Oliver from the engineering team. So yeah, basically we're looking into that for SGX and for ACV as well. We still have to work that into the planning, but it's planned for this year.
Great, thank you.
Great. Anybody else? We have time. Next presentation is at 3. Or maybe you want to go for a coffee. Coffee 1. Thanks a lot.
Thank you, everyone.